Hello, I got a few questions about number 4 in section 2.2 in the online homework. So let's take a look at that. So this is the problem. It shows the daily receipts in millions of dollars excuse me, for some movie. And it says estimate the instantaneous rate of change of the daily receipts on day 119. Okay, so let me just show you the theory. What's happening here is, let's suppose this is the curve of the function, right? And it could be, I don't know exactly what this looks like, but let's just suppose it looks like this. And day 119 is somewhere here, okay? The tangent line to that looks something like this, right? If I want to approximate the tangent line, now that's what instantaneous rate of change tells us. The instantaneous rate of change, remember, is equal to the slope of the tangent line, okay? If I want to approximate the slope of the tangent line, let me look at the point before and the point after the point I'm interested in. So if I'm interested in 119, I want to okay, so I just realized 119 is an endpoint. This is not going to work for endpoints. So if you get like the last point or the first point, okay, then just put in like a fake answer and then redo the problem so it gives you a middle point. So this really only works for middle points. And what I'll do is I'll email the publisher and let him know that there's an issue with the algorithm and not to use, you know, the last point and the first point. But let's change 119 and let's pick any random point in the middle. Let's pick 105. Okay. So let's suppose this is point 105. And so you're going to pick the point before and the point after. And if you find the secant line, the slope of the secant line of the point before and the point after, then that is a good estimate for the tangent line, the slope of the tangent line of the middle point. Okay. So this will be 119 here, and this will be 91 here. Okay, so how do we find the slope of the secant line? Well, it's just a slope. Remember, it's the average rate of change. So you're going to do the y value, so change in y over change in x. And we know the receipts are y, days are x, because days is time, time is always independent. Okay, and this is dollars of receipts or money. So change in y, so let's do 119, so that's our point, that's our later point, the point after, and 191. So you're going to do 0.182 minus 0.624 divided by 119 minus 91. Okay, so the y values minus the x values is the slope. Let me go ahead and minus 0.624, which will be negative, divided by 119 minus 91. Enter. So negative 0.01, and let's take it out a few decimals, 0158. Okay, in millions of dollars. Okay, so that's what you want to put here. That's the instantaneous rate of change. Okay, so you pick a point before and a point after and find the slope of the secant line, and that's a good estimate for the instantaneous rate of change. Okay, now again, this is only the procedure when you have a table of discrete values. And it's not, and it's a middle value. Let's say it's a middle value. So meaning not the last value or the first value. Okay. Again, if you get the last value or the first value, choose the problem. You know, say work on similar problem, or put in a wrong answer, hit enter, rework. You know, get a similar problem. Since it's unlimited tries, and you know you can get a middle point. If it's If it's asking you to find the instantaneous rate of change in a different format, like if it gives you the function, if it gives you f of x, then you're going to do something different. Okay, so again, this is only for a table of discrete values. So if you have any questions, feel free to email me. Okay, I hope that helps.